second paper is uh, from ACE Automation Engineering by Mr. Vineet Taneja on affordable IoT for reliable fluid power systems. Mr. Vineet Taneja, a driving force amongst the hydraulics MSMEs, is a postgraduate mechanical engineer from BITS Bilani. After working with an American MNC for a few years, for the last 33 years, he and his team have been providing solutions in industrial hydraulics and the oil cooling for paper, sugar, cement, steel, gearboxes, railways, and automobiles. He has helped companies to cut down cost and improve profits by up to 19%. With his proprietary SFP framework for heat load reduction in hydraulic systems and optimized selection of oil coolers, is well-researched fin selection for air-cooled oil coolers and for the hot and dusty Indian conditions have helped customers immensely. An acknowledged authority in the oil cooling domain, as a trainer, he has trained over 500 engineers from companies like Toyota, Suzuki, Knorr, Premsi, Yukon, Bosch, and Belgian. As the MD of ACE Automation Engineers, India's premier air-cooled oil cooler manufacturer, Vineet is fondly known as Taneja.com and imbibed through his highly accomplished books, The Ultimate Guide to Air-Cooled Oil Coolers and 7 Reasons Why You Are Crushing Your Profits. He also writes for national, international industry magazines, including Hydraulics and Pneumatics, published in the United Kingdom. For the last over a year, he and his team have been working on developing plug-and-play economical IoT solution for this cooling and fluid power industry. So this paper is all about this, I think. Welcome, Mr. Vineet. Over to you.
Hi, good morning, everybody. It's so heartening to see people driving through Bangalore traffic and coming here in the morning to attend fluid power sessions. I'm part of the organizing team, so yeah, it really is wonderful to see you guys here. So I seek your permission to start my paper presentation. Out here, I'm sure there are a lot of filter manufacturers. So the question I'm going to have a lot of questions for you guys today. So one of the questions is that filter manufacturers here, how valuable is the information that a particular filter in a specific industry is going to, if you could predict fairly accurately when the filter is going to get choked, or for a pump manufacturer to be able to predict when the pump is about to fail, or for equipment manufacturers, when you manufacture equipment, you give it out to your customer and you obviously have a warranty of a year or year and a half or whatever. To be able to, and when you give a warranty, it goes with the obvious understanding that it's going to get used under certain conditions. And when there is a failure, the customer, we can never prove to the customer that, maybe the oil wasn't right or the temperatures weren't being maintained. So having historical data which tells us the real reason, whether it was a problem with the equipment or was it the environment which caused the failure. So do you think this kind answers to these questions would have immense value for all of us? So that's the space I started working on this. And one of my mentors, right in the beginning of my career, brought in this thought in my head that if we worked with the intention of helping clients, it would always work well for our business, and that's been the guiding principle for almost 30 plus years that I've been working. But today I come with a different space. I need your help in making our project move forward. So I'll have, as we move through the session, I'll have a lot of questions for you and would seek your support. So Gurpreet, do we have 2-3 mics around? So I believe together we can make IoT help us in predictive maintenance, improved equipment life, optimize the product selection. When I say optimized product selection, data-based, big data-based product selection, and eventually increase profits for our customers. So the agenda today is going to be a demonstration of the IoT system that we've developed. I'm sure all of us have heard IoT, Internet of Things, and probably a lot of you know about it, but to bring everybody on the same page, I'm going to talk about what IoT is. Similarly, Industry 4.0, we've all been hearing about it, but to bring everybody on the same page, I'm going to talk about what Industry 4.0 is, the benefits that all of us can reap from this, business relevance to my business, but I'm sure similar lines can work for almost all of us here. Our journey through that space, what I think an ideal IoT system should be, basics of IoT, GSM-based IoT. IoT can be triggered with various formats, Bluetooth, Wi-Fi, GSM. What we are talking about is a GSM-based system. And then how we move forward from whatever we've done so far. So to demonstrate, we built one small unit, which my team got ready in 3 days. My only guidelines to them was that we're not going to buy anything for this thing. So they have to use stuff that is already in-house, either for surplus from another project, or we'll just loan it from another project and give it back to them once we are through. So brief description, this is an oil tank in which we fitted a heater to quickly heat the oil, otherwise I wouldn't be able to do it in 20 minutes. There's a motor pump assembly, which is pulling the oil from the tank, passing it through 2 filters, with one working, one standby, going to an oil cooler, exiting from the oil cooler and going back to the tank. We have some sensors built into the system. I'll come back to the sensors later. And we have this huge IoT device. This little baby is doing all the job of capturing data and transmitting it. I'll come back to it later, but to move forward, I need 3 volunteers to give their phone numbers, which we'll feed, and as we move forward, you're going to get SMSs. So can I have 3 volunteers, please? Anybody who does not have a problem sharing the number, please, please. Mics.
988-6214-012.
Have you got that number?
988-6214-012.
So, who's noting down numbers here? I can't see. Ashwin. Ashwin's number you've got? Okay.
012.
9027 346789. 9027 346789.
Yeah, 9686449494.
Can you switch to the dashboard for a minute, for a second? Few seconds rather.
In case anyone gets any OTPs, please don't share them, okay?
So this is the oil temperature, ambient temperature, air temperature. This sensor here is just kept to capture the air temperature. And if the fan is on and the filter is clean, plus along with that, I'm getting the temperature reading, time, and if there's an alert, we switched it on earlier, so one alert has already gone to, I don't know, my phone maybe. And as you can see, the temperature is dropping because the fan is on, the heater is off, and the fan is on, and cooling is taking place. As we move forward, this is programmed to switch, and the temperature will keep rising, and we will see it. So can we go back to PPT, please? So what is IoT? It's a very common term. We've all heard about it, Internet of Things. The term was coined in 1999 by a British technologist, Kevin Ashton. But in itself, the concept has existed since even before I was born, 1960s, at the time of RFID technologies. And network devices started appearing way back in 1980s. A brief definition of an IoT system is a network of objects connected to the internet that can communicate with each other. Right? So next step of IoT was Industry 4.0. The term was coined way back in 2011 in Germany. It was thought to be the fourth industrial revolution, and Industry 4.0 is basically about use of digital technologies, which is IoT, to transform manufacturing and industry. So it's been since 2011, it's been 14 years, 13 to 14 years. Has the manufacturing industry in India actually transformed? In 14 years, I don't know. Tell me, guys, are we actually using IoT and Industry 4.0 to do things in this country in manufacturing? Are we? I don't see it. I don't know. So that's. So has it transformed? That's my question to you all, to take back with you. And if you have, I saw some heads nodding. Have you used the IoT systems in the fluid power industry? If you have, was it developed in India? What was the kind of installation cost that we were talking about? And the recurring cost of that system? I'm basically killing time. I'm waiting for the oil to heat up. So how will it benefit us? It'll help us make reliable equipment, increase productivity, database decision making, reduce cost, higher profits, sustainability and safety, and of course capturing big data, historical data, which can empower us to take better decisions. How is it relevant to my business? This is what we do. We manufacture cooling systems for hydraulics, large gearboxes, drilling rigs, now EVs, fluid couplings. Now, whenever I would go or my team would go to clients and start talking to them about heat dissipation, they would never be able to give us accurate thermal data. So they don't know how much heat their equipment is producing. And when we drill down deeper, I'm going to talk about two cases. One of my customers makes drilling rigs. Their design told me that you expect data, but you have to understand our point of view. This same drilling rig is used for quartz drilling, granite drilling, piling, bore well, and many other applications. Similarly, another customer who makes planetary gearboxes, their answer to that, to my question of not being able to get accurate thermal data was again this, that the same gearbox is used for conveyors, agitators, mining equipment, machine tool across the world, across various locations. Ambient temperatures are different, duty cycles are different, so how do you expect us to give you accurate thermal data? So that's where my journey started in terms of having a system which would give me accurate data, and we could start taking smart decisions as far as cooling was concerned, oil cooling was concerned. So I started exploring solutions in IoT. Uh, as a student, though I was studying mechanical engineering, I was very attracted to IT. I did a lot of courses on IT, and so I was quite excited to get into the IoT space and start talking to people at exhibitions and other places wherever I could meet them. And all I got was a barrage of acronyms which I had no idea what they were talking about. And they were talking big budgets, talking about, I don't know, a lot of stuff. And I was scared, and I thought I was safer in my fluid power domain and shied away from it. And then my moment of eureka came when a niece in Germany sent me a WhatsApp message of her 3-year-old son all the time playing with IoT. This is an example. This is a part of the WhatsApp message that I captured. Where it's not playing, but it's a small video clip in which this 3-year-old kid is asking Google what's the time, and Google is telling him what's the time. He's going around switching on lights, switching off lights, and I thought that a 3-year-old kid is so happy using the internet, and I am a 40-year guy with 40 years of experience, and I shied away from the stuff that people told me. So I got back into action. So an ideal IoT system for me, it was an easy to use, plug and play, user-friendly, standalone, inexpensive, reliable, consistent, giving me same data each time, and low running cost. And yes, small in size. The first unit we made was a Wi-Fi based system, which was this big. And yeah, I mean, now we've managed to reduce it to such a small size. So can I see the dashboard, please? So data got breached. Can you see it? The data got breached and everybody got an SMS. And I can see that an alert was sent, at the time at which it was sent, the temperature. And the moment the alert was sent, the fan came on and the temperature started dropping again. Can you go back to the PPT, please? Right, so in a nutshell, IoT system is a equipment like this, connected. There are some sensors built into the system. There's a small processor which is housed inside this, is processing the data coming from the sensor, transmitting it through the cloud using Wi-Fi, GSM, or Bluetooth. We are using a GSM, sending it to a server which is processing it, and if you've set some breach points, it'll send information to the user who can, and then either directly, manually interact with the equipment, start something, stop something, whatever. So this is the test setup that we have in our factory. A test unit connected to similar stuff without the jacket, which has a SIM. You can see a SIM here. And using the cellular tower, it's sending information, getting processed, and one can see it on their desktop and phone and get alerts. If you're willing, you can, the same dashboard, you can scan the QR code and you'll all be able to see it. I can see it on my phone as well. So how it works is it uses the cellular network, 2G or 4G, real-time alerts over cloud, simple installation, simple monitoring, and preset alerts can be sent. I guess we would have got 2 alerts, one about the temperature and second about the fan getting switched on after some time. Is that right? 2 alerts? You can monitor the data. Historically, I can set the the time, last 5 minutes, 15 minutes, 16, I can go back to as long as the data has been stored. And so this is the kind of alert that goes out. Over temperature alert, temperature range breached, and then similarly a fan switched on, etc. And so in my eyes, we've managed to put a tick to all the points that we thought should be an ideal IoT. Now, this is where I need your help. I need you to scan this code. You come to a form. Please fill it up, and it gives me, sorry, I will evaluate for free what we can do together and develop this thing from the user perspective. We're already working with 3 customers. I'd be happy to work with a few more different applications. Of course, I don't know whether we'll have an answer for your application, but if you fill up the data, I can talk to you, or my team can talk to you, and we can start talking about providing a solution, the costs involved, etc. What I can promise is that we will do a no-profit kind of thing, and these are cheap devices. We are not talking about big budgets.
We already lost time. Please close.
All right, I'm almost there. So moving forward, it basically implies integration of, there's a sensor today. Sensor technology is way ahead. So there's a sensor for almost everything that you can think of. Pressure, filter clogging, flow, RPM, voltage, current, speed, contamination level, differential pressure, anything else that you would like, we can figure out how to have that sensor communicate with this device and have a solution for you. So you could, 2 choices. You could forget about whatever I said. Like I shied away, you can shy away and go back to life as usual. Or meet us at a stall behind in the next hall. And you can see this demo for yourself and give us your inputs on how we can take our work forward. Thank you, guys.
Thank you, Mr. Vineet. This is a unique presentation with connecting a live demo with the audience. Over to audience for any questions.
Mics, please. Yeah.
Sir. Hello, sir.
Yeah, I can't see you. Yeah, okay, tell me.
Thank you for the presentation, sir. We could actually get to understand a lot. And since we are also working in the similar domains, although we have a different application to work with.
Could you please introduce yourself?
I am Arpit. I am a PhD scholar from IIT Indore.
Okay.
So we want to...
You have a session today. I'm looking forward to it. Yes. Okay, please.
So we want to understand the device that you have made.
Right.
It's a Bluetooth device.
It's a GSM-based device.
GSM-based device.
Right.
So we want to understand that, is it like in-house developed or your patented device, or is it available in the market?
No. Available in the market.
All right, all right.
So we've just done the selection part. Of course, technical details, my colleague at the back, Tanmay, is the right guy. Specific, if you want to talk about the hardware, he'll be your right contact. So you can meet him after.
All right, all right. Thank you, thank you.
Good morning.
Morning, sir.
I'm quite impressed with this cooling system gadget. So I have one cooling system for my application, which is used in the helicopter engines.
Okay.
Okay, it's an oil cooling system.
Right.
So it's got a valve. There's a heat exchanger attached, all mechanical, plus a valve, mechanical valve.
Right.
What it does is the gearbox of the engine works better when it is the operating range is within a range of temperature.
Perfect.
Okay.
Right.
And what does this valve does is it ensures that the range is maintained continuously during the operation.
So it's like a thermostatic valve, or
yeah, thermostatic valve.
all right.
So it ensures that continuously the temperature is maintained.
Right.
Either it doesn't exceed, doesn't become less also, so that the gearbox is optimum. Now, how do you think this IoT solution will help this maintaining this oil cooling system?
I'm assuming that the thermostatic valve is not solenoid operated from your question.
It's not solenoid operated. It is not.
So it's that wax-based system. We use those similar.
Wax-based system. Currently we are importing that.
We also import it.
Okay.
So I don't think we can use it directly. You need a sensor, right? I need to have a temperature sensor or a solenoid valve and do switching electronically or electrically. Per se, with a thermostatic valve, I don't think it'll work. I have to get a sensor. I mean, I need an input.
So it's not. So you're saying at the moment the solution is not there.
No, the solution is there. I need a temperature sensor.
Okay.
So I'm getting similar. We're getting temperature input, and I can switch on, switch off.
And the reliability of this between the wax-based solution and IoT solution?
I don't know. Yeah.
Okay.
I'm not competent.
I would like to further discuss on this with you.
We also, for oil and gas, we use those thermostatic valves. We import them and use them. But I think, though they are not 100% leak proof and all that, but they're more reliable because it's basic physics. I'm not talking about electronics, no gadgetry that he can't fail. That is why I guess in critical applications they're still used.
Okay, thank you.
Are there any more questions?
Yeah.
Doctor. Yes, sir.
Prasanna Kumar, there is no question, there is an observation in your favor. People here may remember or may not remember. FPSI conducted a full 2-day seminar like this in 2017-18 on IoT in fluid power.
Okay.
Because in December, around that, Seshnath was there in Pune attending an exhibition, and he told me that most of the stalls were displaying IoT and other details. Then we took it and I arranged an IoT seminar, IoT national seminar like this 2-day. And JCB, L&T, Komatsu, Hyundai, and so on and so forth, and other people like Bosch, everybody participated. It was a roaring success. That is the point. Over. After that,
sorry?
there is no penetration at all. What I am telling is, I am really surprised and I am really pained that when such things come, for example, this is Industrial Revolution 4.0. Bosch has introduced it here from Germany, right. And it is using for so many machine tool installations are using it. Right. Fluid power installation are using it. When I asked that fluid power, some of the people who participated in this seminar, later I did a survey for 2-3 people.
Right.
I told him, for example, one component, say cylinder in that one. Why don't you fix up some sensors so that you know at least have a maintenance feedback? Right. He replied, no, it will cost another extra money, and it will be reported. Who? By service engineer in the field. I told him, what Komatsu was doing is, from the factory they were finding out what is happening in the field so that they can take a preventive measure. But the penetration is very low in India, and unless this Bosch type of thing, this Industry 4.0, what you are telling, You have to make a missionary zeal. I am very happy that you are doing it, to make it penetrate to all the people so that it can be used. For example, last FPC, one group of girl students from a college in Coimbatore did that IoT.
That, sir, is precisely what got me started again.
Yes.
I saw those two girls,
Yes.
apart from my grandnephew, I saw those two girls on stage. They had a device,
Yes.
and they made it work. And I thought, what
Yes.
the hell? They're second-year students, and I'm
But
a qualified
it is there
engineer,
in
and I
the
can't do it.
teaching level and student level. It is there in some other level. And the penetration, if it is not there in a country, then we will be always underdeveloped. Thank you.
Okay, I think if there are no more questions.
Thank you, everybody, for bearing with me. Thank you.
So can you please give a moment to Vineet?